Good afternoon. This is a video on fractions. Today we're going to look at a few different things in fractions. Mostly we're going to look at building fractions and how to write fractions in different ways. And then we're also going to look at putting together fractions, adding fractions together. So let's start off with like the real basics, just to recap, because I know there's some people probably watching this who need a little bit of a recap, and also it's nice to just kind of review what you already know as well. So when we're talking about fractions, we're talking about parts of a whole thing. Now I always like to use pizzas as an example because pizzas are the perfect example of fractions in our everyday life. When we have a pizza, we have a whole pizza and we split it into slices, which are the fractions. So in this picture here, you can see we have a whole thing and we've cut it into 4 equal parts. And that's the key thing, fractions. They need to be equal, okay? If they're not equal, then we do not have, I had a bit of trouble writing equal then. I'm trying to write it upside down and I'm gonna flip the video later. It's quite weird. But anyway, as I was saying, fractions are parts of a whole. This is only one piece. So what we say is 1 out of 4 or 1/4. Now, the more we look at different fractions, the easier it will become. This is a square pizza or a square shape. It's a whole thing, and depending on how we look at it, we could take 1 piece, we could take 2 pieces, we could take 3 pieces. Let's take 3 pieces. So we've got 3/8. Okay, so our 2 numbers here that we use to build this fraction are the numerator on the top and the denominator at the bottom. Okay, now as we look at the top number 3, that numerator tells us how many parts we have. We have 1, 2, 3. Okay, the bottom number tells us the total number of parts that we have split the whole thing into. So we are looking at 1, 2, 3, 4, 5, 6, 7, and 8. So that's nice and easy. And let's take another one. Let's take this shape. This shape is out of 3. So before we even color it in, we know that the denominator is going to be 3 because it's 3 parts. I'm just going to color in the middle part here. That's 1 part. So there we go. 1 out of 3. And this lovely thing here is a 3D shape. But again, it's the same principle. I've cut this, I don't know, let's call it a chocolate bar. I've cut it into a number of equal pieces. I've got 1, 2, 3, 4, 5, 6 equal pieces. If I color in, let's have a look, 3 of them, then you should be able to tell me what the fraction is. Have a little think about it. And what's the fraction? It is 3/6. Okay. Now, like I said earlier, it's important that we know the correct vocabulary. So how many have you got? That is our numerator. I'm going to write it again here. Numerator. And how many have we got in the full whole? Well, that is 4, and that's the denominator. I always remember, spelling. I always remember D for denominator, D for down. It's the number that is down at the bottom, okay? So let's have a look at showing these fractions in different ways. So here I've got a picture, okay? Now, this is where it gets a little bit more complicated because I haven't just got 1 whole piece. I've got 1, 2, 3 whole pieces. So I've got 3 pieces here. Let me just write a little 3s to remind ourselves. And then over here, I've got an extra piece. Now, if you look at the holes, they're cut into 4 bits. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. This piece is just left on its own. So this is just 1 part left over, which is obviously 1/4, as you can see here, 1/4. So as a mixed number, the word mixed number here, that implies that I've got a whole number and I've got a fraction. So I've actually got 3, let's pretend they're pizzas again. I've got 3 pizzas and over here, I've got 1/4 left over. That's my mixed number. But that's not the only way I can write this, because I could also write it as just a fraction of how many pieces I have. Well, the denominator is 4 because the whole thing is cut into 4. So let's just keep that as 4. Now, how many pieces have I actually got? Well, I need to count the individual pieces now, not the whole thing. So I know I've got 1, 2, 3 pieces, and I've got a bit left over, a quarter. This time I need to look at how many pieces. So in this piece I've got 1, 2, 3, 4. Let me just write a little 4 here. 1, 2, 3, 4. I've got 4 here. 1, 2, 3, 4. I've got 4 here, and I've got 1 piece here. So I've got 4, 4, 4, and 1. If I add those together, that gives me 13. 13 pieces I have here. 13 quarters. Okay? And when I put the 13 quarters together, I get 3 pieces, and then 1 left over. Okay? Now, if you wanted to take this one step further without looking at pictures, we could do something like this. We could take the improper fraction, 13, and somebody could say, well, how do you know that that is going to be 3 1/4? Well, this is how you do it. Your denominator at the bottom is the big clue. That's the times table that you need. So it's a 4. Everything's in 4s. So I'm going to actually write down my 4 times table because this will help me. 4, 8, 12, 16, 20. Now, I don't need to go that far. And what you'll see is this. Well, it's actually, I'm going to do a bit of a reverse division here. How many times does 4 fit into 13? So 13 divided by 4. Well, let's have a look. I can get to 12, which is 3. And how many have I got left over to get to 13? 12, 13. 1 left over. So it's like a remainder. But it's not just 1, it's 1 piece of this, which is a quarter. So it's out of 4. 1, 3 1/4. You see? Let's try it the other way around and let's see how we get, how do we change this back into 13 over 4? Well, again, this is nice and easy. I love this way of doing it. Basically, you take the whole number, because this is what you've got here, the 3's, the 3's here, and you want to multiply it by 4, because you've got 4 here, 4 here, 4 here. So you want to do 3 times 4, and you can see it at the top. I've got 4, 4, and 4. 3 times 4, 12. But then I've got the extra piece here. This extra piece is just 1 more. So I've got 3 times 4, 12. Add this 1 extra piece here, and that gets me 13. Do you notice that the denominator stays the same? The denominator is always 4, because I'm not actually changing how many pieces I've got altogether, how many pieces it's split into. It's always out of 4. I'm just changing the way I write it. So let's take this one step further. Let's have a look at, let's look at this again then. So mixed number, let's try this one. I've got a shape here, and I don't know if you can see it in the camera, but this shape is split into 8 different pieces. Okay? And the same with this one. It's split into 8 different pieces. And of course, this one is split into 8 different pieces. If we look carefully, we've got 1 whole piece here, and we've got 1 whole piece here. So in this piece, there are 1, 2, 3, 4, 5, 6, 7, 8 pieces. That's what I would call 8 out of 8. It's a full piece. You could also say it's just 1. 8 out of 8 means I've got everything, and it's one pizza. This one here is also full. It's also 8 out of 8, and that means it's 1. Yeah? Now I can write 1 equals 8 over 8, or I could write 8 over 8 equals 1. Doesn't matter, because equals means the same anyway, okay? Whichever way I do it. Look at this one here. This is a bit tricky, because this one now has 1, 2, 3, 4, 5, 6, 7. It only has 7 pieces, so this is actually going to be 7 out of 8. I'm still keeping the 8, because it's out of 8. There's just a piece missing. 7 out of 8. Okay, so that's not a whole piece. So actually, let's just break this down. How many pieces have I got? Well, I've got, how many holes have I got? I've got 1 here, and I've got 1 here. So that's going to be 2. The mixed number is going to show me a whole number. So I've got 2 blue pizzas, but I've got some bits left over. I haven't got 3. I've almost got 3. Instead, I've got 7/8 left over. Okay. Does that make sense so far? Good, I hope so. As an improper fraction, well, we can do the same thing. We can just count the pieces. Now, the word improper comes from proper. Proper is good, it makes sense. A normal fraction has a numerator and a denominator, okay? And the numerator is always smaller, like this one, 7/8. But the improper, it like kind of means incorrect. It's not a real fraction. Well, it is a real fraction, but it's not a fraction that you normally see because the top number is going to be bigger now. Because the denominator is 8, as we established earlier. The denominator doesn't change. But now we have, instead of 2 whole pieces, we actually have 8 and 8, which is 16. So instead of writing 16, I still need to add the extra pieces. 16 here and here. 17, 18, 19, 20, 21, 22, 23. 23/8. Okay? You'll notice that this number is a lot bigger. That's why we call it improper. Okay, let's look at the one underneath. Again, we've got, now this is tricky. I've done this now to make it a bit harder. Let's break it down. We've got a couple of different shapes. Let's call them chocolate bars. We've got 3 chocolate bars, and each chocolate bar is cut into 3 pieces. So already, if I'm thinking about a mixed number, I know that I don't know how many I've got altogether yet because the way they're colored in, but I do know that my denominator is going to be a 3, okay? It's going to be a 3. Now, looking at the picture, I haven't got a whole chocolate bar yet. I've got 1/3 here, I've got 1/3 here, I've got 1/3 here, and I've got 1/3 here. So I can't actually make a mixed number yet just by looking at it. So why don't I do the improper fraction first? Why don't I just write that the improper fraction is, how many thirds do I have? Come on. 1, 2, 3, 4. I have 4 thirds, or 4/3. So how many do I have altogether? Well, if we use the idea that I made earlier where we were looking at, where is it? We were doing this. We were dividing. Let's do the same here. How many times does 3 go into 4? It goes in once, so that's going to be the 1. And then how many have we got left over? 1. 1 and 1/3. And let's try this now in a different way. If I got rid of this one and I put it here, can you see now that I've got a whole thing here now because I've moved this. Let's pretend this is gone. Now, I never ever would say do this in your book, but I'm just going to do it here just to make it clear that this is gone. Now I've got one whole thing here. There it is, 1. And I've got just this little third left over. So it works, it does work. Now, you can obviously go back and watch this bit again if you need to go through it again. I'm going to now move on to the next part where I'm looking at adding fractions. Okay, now I haven't got any pictures here, I've just got some sums, some questions. Now I call them sums because we're adding fractions, and the denominators are the same. Can you see here I've got 3 and 3, I've got 12 and 12, 9 and 9. If the denominators are the same, it is super, super easy. Check this out. In all the questions, the denominator stays the same. So 12 and 12 here, that means the denominator here is going to be 12. 9 and 9 here, the denominator is going to be 9. 6 and 6 here, the denominator is going to be 6. 13 and 13, the denominator is going to be 13. So that stays the same. The trickiest part, which is actually really easy, is adding the numerators. So denominator stays the same, the numerators we add them. 1 and 1, 2. 7 and 5, 12. Ooh, 12 out of 12. We could say that is just 1. 2 and 4, 6. 6 over 9. 7 and 2, 9 again, but it's 9 over 13. And 6 and 2 is, why am I saying 6 and 2? 3 and 2, 5. Now, how easy is that? You just add the numerators. Add the numerators. The denominator stays the same. Now, this is all easy if, only if, the denominators are the same. If they are not the same, then we have to do something different. Let's have a look at this one. So what if the denominators are different? Here I've got 3 over 15, and here I've got 2 fifths, 2 over 5. If I want to add them together, I can't, because remember we said that we keep the denominator the same. Well, here, do I put a 15 or do I put a 5? I can't. I have to have them the same. So this is what I'm going to do. I need to think about how I can make this 15 or this 5 the same. Now, I know that in my 5 times table, I have 5, 10, 15. So I know I can turn this 5 into a 15 to make it like this one. I want to make them like, I want to make them the same. So how did I get from 5 to 15? Well, I just times by 1, 2, 3. 5 times 3 is 15. So now, let's try this. Let's keep this one as 15. So this one does not change because we've just times by 1. 15 times 1, 15, 3 times. It's the same. This one, now I've times 5 by 3 to make 15. Now I need to do 2 times 3. 2 times 3 is 6. Aha! Now, check this out. The 2 15s are there. That means my denominator can be 15. 3 and 6 is 9. 9 15ths. Now I have my answer. Okay. Now, if I wanted to, this is just a bit of extra information. If I wanted to, I could make this smaller. And I could do this by simplifying. Now I could think, right, what is a factor of 9 and of 15? Now, if you practice your times tables, you will know that 3, 6, 9, 12, 15, there is my 3 times table. It has a 9 and it has a 15. So how do I get my 9 to be a 3? Well, I just divide it by 3. Now I have to do the same to the 15. Do I know that it's divisible by 3? Yes, because it's in the 3 times table. As long as I do the same thing to the top and the bottom, divide by 3, I will get the right answer. And I can shrink this down to 3 and this one to 5. So there's a simpler answer, okay? Now, if it's getting complicated, just go back, rewatch it. Start doing some yourself, okay? I'm gonna give you a few ones to try. You could do something like 7 tenths add 2 fifths. Let's just try it together. What are you gonna do? Well, 10 and 5, they're different. We need to make them the same. So, how are we gonna do it? This 5 I can turn into a 10, yes. So, I'm gonna keep this the same, 7 tenths. But I'm gonna change this one. Whatever I do to this number, I have to do the same to the top number. So I've got 5 times 2 makes 10. So 2 times 2 is 4. Now I can add them together. 10 is my bottom number, that's nice. 7 and 4, you've got 11. Aha, an improper fraction because the top number is too big. How about we review what we just did, and let's turn 11 over 10 into a mixed number. Remember, a mixed number gives us the whole and the fraction. How am I going to do it? Let's have a look. How many times does 10 fit into 11? Which is 11 divided by 10. It goes in once, with 1 left over. The denominator stays the same, 1 and 1/10. There we go. Right, let's try some more. Let's try some more adding fractions. Let me just throw these away. Where am I? There we go. Okay. So, here's a problem. In fact, I'm going to come back to this because this is a bit trickier. Let's look at equivalent fractions first because we need this to do that. So, here in this picture, as you can see, I've got 1 1/5. And 1/5 is the same as 1/5. Easy, because they are equivalent, they are the same. Okay. Here, I've written that 2/10 are now the same, equals means the same, as 1/5. How is that? Well, as you remember from earlier, when I simplified it, I can connect these two together, can't I? Yeah. So actually, if you look at it, if we go backwards, 5 times 2 is 10. 1 times 2 is 2. Okay. If you go this way, you could obviously divide. It doesn't matter. So if we look at these fractions here, we can actually change them into a different fraction that is exactly the same. And all we have to do is do the same thing to the top and to the bottom number. So for this one, I can do anything I want. I'm going to times by 3. And as long as I do the same thing to the top and the bottom, I will get the same fraction, or an equivalent fraction. 2 times 3 is 6. 6 times 3 is 18. And there it is. There's my new fraction, but I can say it's the same because they're the same. If I have a pizza that has 6 pieces and a pizza that has 18 pieces, if I have 2 of those 6, or if I have 6 of those 18, I'm going to get the same amount. Let's try 3 over 4, 3/4. Again, whatever I want to do. I'm going to times this by 10. Why not? 3 times 10 is 30. 4 times 10 is 40. And there we have it, another equivalent fraction. It's all about knowing that we have to do the same to the top and the bottom. And basically, it's like a seesaw. You want to keep it balanced. 4 and 7, 4/7. What can we do? Well, I don't know. Let's times it by 2. There we go. 4 times 2 is 8. And 7 times 2 is 14, 8/14. And we get an equivalent fractions. So it's important to remember, I've written a little note here, we can only do this by multiplying or dividing. Okay? There's a big misconception by adding. You can't add numbers and get an equivalent fraction because it doesn't work that way. You can't add a piece and add a piece to the bottom and add a piece to make it the same, because it skews it. It makes it slightly different. You have to multiply and you have to divide. Okay, that's really, really important. So to finalize this lesson here, let's go to this problem. This is where it gets complicated. 7 people want to share 10 bottles of water, and we don't want to waste any. So usually, if you were going to say, right, 7 people, I've got 10 bottles of water, you'd give each person a bottle of water to get to 7, and then you'd have these 3 left over. And you obviously can't share these 3 bottles between the people because there's not enough. So we're going to do this in a different way now, using fractions. We're going to turn a remainder into a fraction so that we can share it. So let's do this using our written maths here. So the question says 7 people, and we want to share 10 bottles, okay? So am I going to have 7 divided by 10, or am I going to have 10 divided by 7? That's the first thing that we need to work out, because with division, that will give us 2 different answers. Now, obviously, you've got to think about this logically. Is it the people that we want to share, or is it the bottles that we need to share? It's obviously the bottles that we need to share. You can't share people to bottles. You have to share the bottles with the people. So the bottles is 10. So 10 is the question. 10 is the dividend. 10 is the dividend, and 7 is the divisor, because we want to share the 10 bottles between 7 people. So remember, in a question, sometimes the numbers are not the right way round. You need to think, what am I sharing? And it's the dividend that you are sharing. Okay? And the divisor is how many you are sharing it between. So actually, I'm going to get rid of this because that's going to confuse us. So we know that we've got 10 bottles, and I'm going to write bottles here. And we want to share between 7 people. So let's do our normal division. 7 divided by 10, 7 times table. How many times does 7 make, how many times do I need 7 to make 10? Well, it only fits in once. 1 times 7 is 7. That means I've got 3 left over, 8, 9, 10. So that's remainder 3. Like we said earlier, we've got 1, 2, 3, 4, 5, 6, 7 bottles. 1 bottle for each person. And then we've got these 3 left over, which we don't want to waste because that's just a waste of plastic and a waste of water. So this is what we are going to do. We are going to split these bottles, these 3 bottles up so that we can actually share the water with 7 people. So if you're going to split up a bottle to share between 7 people, what are we going to split it into? Exactly, 7 pieces altogether. So this bottle is going to be 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7. There we go. 6, 7, 1, 2, 3, 4, 5, 6, 7. So we split up each bottle into 7 parts. Now, how you do that in real life doesn't matter. But mathematically, 3 bottles are now split into 7 parts. Now, the remainder tells us that we've got 3 bottles. We split those 3 bottles into 7 parts. So now, let's think about this as another division question. How do we share? Well, let's have a look. How many have we got? 1, 2, 3, 4, 5, 6, 7 parts. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. How do we split 21 parts between 7 people? If you know your 7 times table, you know that the answer is 3. So really, if we do this, if we just colour these in. So the person who gets this bottle, this is person number 1, person number 2, person number 3, number 4, number 5, number 6. So these bottles go to each person. Then you're going to give 3 parts to person 1. You're going to give another 3 parts to person 2. Ooh, there's a little bit left here. 1, 2, 3. 1, 2, 3. Now I know this is a complicated way of doing it, but I'm just visualizing how it looks. 1, 2, 3. And 1, 2, 3. And 1, 2, 3. And now you've given away all the water. So person 1 is going to get 1. And how many parts? 3/7. He's going to get 1 and 3/7. Person 2 is going to get 1 bottle and 3/7. So now they all have the same amount. They all have the same amount of water, which is really, really good. Yeah. We'll do some more on that, I think, very soon. I'll make another video where I'll go over it again a bit clearer, and I'll also do some more of this in class as well, so we can practice getting that routine of dividing, taking the remainder, and then dividing the remainder up as well, so you don't have any waste, okay? Okay, guys, that was fractions. Hope you enjoyed it. Again, practice at home. Make sure that you have enough time and enough energy to sit down and really, really just mess around with numbers. Just get a piece of paper, like I have, and just start messing around with numbers, yeah? Play with them. Like, instead of playing on Fortnite, get a piece of paper and play with some fractions and some numbers, and get your brain working in that way. It will really, really help, okay? Well done, and see you soon.